Now we'll talk about how this conversion is done. And as we told that why the digital signals, because any signals, so connecting the digital circuitry to the sensor device is simple. And the digital signal, as you know, that it is a high-low kind of thing. So any relay or encoder, or which is the on-off switch, this kind of implementation we can easily do with the digital signal. We cannot do it the analog signal that easily. So for that purpose, and also main purpose is the transmitting, signal processing, storage, use of computers. For those things we need the digital signals, and that's why we need to convert always that analog to digital. And whenever for our needs, when we have to use this signal, so for that we need to convert the digital signal again to analog, so that we can understand, that is for our understandable way. Okay. Now we'll see that how this analog to digital conversion is done. So for that, you can see that this is an analog signal. So two things are done, means from analog to digital if you want to convert. So first one is the sampling, and the second one is your quantization. So what does it mean by these two terms? So we'll see one by one. So this is an analog signal. Okay, so it is continuously varying with time. Now we are actually, now what we are doing, first we'll do this sampling. So you can see this is a sampling. So what does it mean by sampling? Sampling is converting that continuous independent variable. Here is the independent variable is time. So independent variable, you are converting that independent variable to discrete. So continuous to discrete value. So that is actually called sampling. So here the time is, if you can say, it is infinite, but you are actually defining it. Now this small delta t. So at any interval, what will be the signal value? So this interval you are actually breaking the time interval, so continuous to discrete. So that is actually called sampling. So it is discrete time but continuous values, because if you see that at each point, so at each point you can see that is the continuous variation of this amplitude. So amplitude is continuous, but time is, you are discreting that time. So this is the first step. And then what is the second step? Second step, you are this analog signal, you are actually dividing the voltage, means dividing the dependent variable. Here the dependent variable is your this amplitude. So you are dividing that dependent variable from continuous to discrete value. So here independent variable is divided or breaking into continuous to discrete. And here you can see that in the y-axis, so or basically you can understand in that way. So x-axis is actually continuous to discrete for the sampling, and quantization, the y-axis is made or you can break into continuous to different discrete level. So discrete level, so you can see how many levels are there. So you can if you increase the number of levels, you can increase the resolution. We'll talk about that later. So this dividing or breaking into discrete level is called the quantization. And mixing of these two, so that means that you are dividing it in x-axis and also dividing in y-axis. So both sampling and quantization, if occurs in for an analog signal, that is, we are calling that the digital signal. So you can see that it is divided, both y-axis means the quantization is done, and in the x-axis, so that means sampling is done. So you can see that now it is in the sampling, it was continuous time, continuous valued. Okay, but here you can see there is just, it is holding that level. So in between these two levels, let's say between this level 3 and level 4, there is no value. It is just constant here. Again, in between these levels 3 and 4, it is constant at level 4. So that means that it is discrete time and discrete value signal. And this signal we are calling at digital signal. So to convert an analog signal to digital, we need to do sampling as well as the quantization. Is it understood?